Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, will the VR make me sick? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is all about teleoperation. I'm finding out how cutting-edge virtual reality technology is set to transform remote tasks in hazardous environments and beyond. Before we get started, I'd like to remind you to subscribe to Robot Talk through your favourite podcast provider. It really helps the podcast and means you'll be the first to hear the latest episodes. Another way to find out about new episodes is our email newsletter, which you can sign up to on our website by going to robottalk.org. And don't forget to enter our competition for a chance to win your very own Robot Talk t-shirt. For more information about the competition and how to enter, check out robottalk.org. So, without further ado, I'm excited to introduce this week's guest. I recently had a great chat with Chang Liu from Extend Robotics, all about teleoperation, virtual reality, and software. Today I'm talking to Chang Liu, CEO and Chief Designer at Extend Robotics, a robotics software company developing human-robot interface software that enables non-robotics experts to operate robots from remote locations. Hi Chang, I'm excited to have you on the podcast.
Thank you for having me, Claire.
So you founded Extend Robotics in 2019, and prior to that you were working on aerial robotics at the University of Southampton and then Imperial College London. So what inspired you to move into the field of teleoperation?
Yeah, I spent a lot of my time in aerial robotics, mostly working on algorithms to automate navigational problems. So I did my PhD in University of Southampton on high precision navigation for drones without GPS.
Okay.
And later then in Imperial College, continuing the Orca Hub to develop applications into inspection maintenance work for offshore platforms, such as using drones to put sensors onto oil pipes or wind turbines to collect erosion data, those kind of the examples.
Yeah.
So teleoperation generally for drones is more like remote controller with joysticks. So we ended up having to get trained to become a drone pilot and always in standby in case that the automation software does not work.
Yeah.
Not to the level of racing drone pilots, but we did spend a lot of time practicing.
Yeah.
Really almost like rewiring our muscle memories to cope with the joysticks and reoriented ourselves from drone's perspective, which turns out to be very challenging.
Yeah.
So I think there's going to be a better way, more intuitive, natural way of operating robots in general. So I kind of thought VR is the good next level interface with this more immersive experience and gesture input. And also during this period, we did a lot of real world demos and tests, most of the time as a proof of concept. So it's okay to demonstrate partially working system in those demos with ideal assumptions. But really, I quickly realized the way we're programming those robots with those kind of traditional handcrafted automation approach. Basically, you set their code process. Those really not really practical in real world. So with these automation demos that really we want something that is truly practical and robust in real world. There's a big gap there.
Yeah.
So similar to autonomous driving problems, like robotics in real world is also what we call long tail problem, which is kind of a lazy way of saying that the particular problem is in the ideal case scenario it's kind of reasonable to solve, but extremely hard to handle those huge variety of edge cases from those long tail of problems. Because this real world is just so complex and extremely high degree of variabilities and unpredictable. So I believe that this requires a radically different way of approaching real world automations. So instead of traditionally handcrafted script by engineers, we would develop something that is for real world, what we call it embodied AI, to continuously improve themselves in real world data. And with the massive amount of, for example, user demonstrations from those remote operational interface. So that's kind of the idea. I really started Extend hoping to solve these challenges and really putting human in the center of technology revolution to create this collaborative relationship between human and robots, and at the same time scale the data collection to advance this embodied AI to ultimately, what we call it, amplify the world's labor productivities. So that's kind of the inspiration why we kind of wanted to start at Extend at the beginning.
Sure. It must be quite a big transition from academia into kind of the world of entrepreneurship.
Yes. It's a different way of thinking.
Yeah.
Obviously, in academic, there's a lot of to advance the knowledge in the world, but in the learning of the entrepreneurial, it's really how do we create the most impact in a more tangible way. Either part is quite helpful. But we kind of made that transition in my life.
Yeah, fair enough. Yeah, I mean, I guess we need both sides of that coin to advance technology.
Yeah, exactly.
So can you tell me a bit about the human-robot interface software you've been developing at Extend?
Yeah, so the problem of today's robot control interface, I believe, really sets a large barrier for people to utilize them in a wider market. So teleoperation robot is nothing new. So it was invented 50 years ago, but mainly for surgeries, nuclear, space, and military applications.
Yeah.
Really not in everyday life. The reason is really because their interface are custom equipment based on joysticks or exoskeleton type of interface with a lot of 2D screens. And they're very expensive and hard to use. So they require highly trained professionals, for example, to operate them, but still result in slow operations and stressful workload.
Yeah.
So we really want to break this barrier. So our goal is to build the world's most intuitive and scalable interface to operate a wide range of third-party commercial robots to enable this remote physical workforce through metaverse, robotics, and AI. So it's based on extended reality technologies, meaning virtual reality or augmented reality or even mixed reality.
Okay.
Enabling those subject matter experts, not necessarily robotic experts, to intuitively operate robots over the internet with a simple gaming VR headset, just like Meta Quest or HTC Vive or hopefully later the Apple Vision Pro. So that's the interface. Right now, to use it, very simple, just 2 simple steps. First is someone who have a robots already just needs to buy a peripheral upgrade kit from us, or they can load the firmware themselves on their computer. And we can support a whole range of robots already, and then the sensors with the cameras. So that's all supported. So they just need to upgrade the robot with that peripheral equipment. And then the second step is to simply download a VR game into your headset. We already distribute our app through Meta, Steam stores. So not much different from traditional VR game. Not traditional, but I guess everybody plays standard VR games. But the difference is really suddenly with that you can operate real physical robots with your gestures, 3D visions, and through a standard network you can remotely operate them over the internet.
That's really cool.
Yeah.
So can you sort of describe what would I see if I put a VR headset on and was controlling a robot remotely using your software?
Yeah, essentially, you will be feeling like you're teleported right next to robots. And then you can pretty much pull the robots around, pull the end effector of the robot around, and then the robot would react to your movement. Essentially, you would turn robots into the physical avatar of yourself remotely. You can operate it in real time. You can also program the robot remotely with your gestures by recording, replaying your past operations.
Oh, cool.
So it's not only real-time operation, but also programming the robots remotely. We're also working on learning-based approach. That is the next step we're taking on. So with learning-based approach, the automation would become more adaptive to changes to the environment, not necessarily repeating blindly your movement, your recordings, but it would intelligently respond to the changes. We hope by creating a super intuitive human-robot interface, unnecessary cloud infrastructure, combining with embodied AI, not only for the purpose of teleoperation, but more broadly to accelerate the advancement of real-world automation through this large-scale fleet learning as a kind of infrastructure to advance the productivity of all physical labor tasks.
Yeah, I mean, I can imagine this could have a huge impact on a lot of different industries.
Yeah.
So last year, you showed off the precision and dexterity of this software, and also its kind of intuitiveness, I guess, by getting a human to play a game of Jenga by remotely controlling a robotic arm. Now, having played Jenga myself, I think that's very impressive. It's not an easy thing to do, even when you're controlling your own arm. What were the biggest software challenges in making that happen?
Yeah, so we have quite a lot of videos on YouTube, on Extend Robotics YouTube channels. Mainly to showcase dexterity, precision, and speed when using our VR interface. Although people find it really, really easy to use, almost take that as grounded. But there's quite a lot of technical challenges we have to solve. I may pick three to talk about. Sure. For example, one of the biggest key challenges is the accurate depth perception when people using robots remotely, especially. So when you interact with physical objects precisely, the ability to judge distance accurately is really important.
Yeah.
So imagine when you try to poke two of your index fingers together with only one eye open. So it's definitely a lot harder than you think. So that's kind of funny experiment normally when you do. So this kind of missing depth perception. This is typically missing in 2D videos, for example, when we have this video call that you can't judge the distance. So even with stereoscopic videos, more modern scenarios, it's kind of the video that's recorded by two cameras that mimicking the two eyes. So even with that, the depth perception is very fuzzy or sometimes even wrong because the distance between the two cameras are different from the distance between every people. So we work with 3D cameras, commonly called RGBD camera.
Okay.
Which basically measures the colors, but also the depths together in a very high precision and resolution. So what we do is in our VR application, we transmit and render those 3D data indirectly as a virtual object in the game. And this gives accurate 3D perception to the user, as accurate as the sensor can be, really, and overlaid a high definition texture on top of the 3D structure. So it's really transforming the way you look at 3D perceptions. It's quite hard because you need to make it super efficient with low latencies, low bandwidth for these 3D data. And you can't really use those traditional compression and streaming techniques, because with normal videos, user is less sensitive to noise, for example.
Right.
And with 3D, noise meaning artifacts, that is quite visible. So we have to almost reinvent a new way of doing this compression and streaming of 3D data.
Okay.
So we have developed this custom codec to be able to achieve that with really low latency, under 50 milliseconds for the compression, and we can reach the high quality as statistically lossless compression. The compression ratio is also important. We can achieve over 1,000 times compression. So it's quite off the chart when we compare to what's available in the market. Yeah, so that's one challenge. The second, I would say, motion sickness, which is really,
I definitely suffer from that.
Yeah, so motion sickness is generally introduced by immersions. Whenever you talk about the immersiveness, biggest question people would say, motion sickness, what about motion sickness? But fundamentally, it's normally introduced by those, what we call motion to photon latency.
Okay.
Is a technical term meaning the delays between users' head movement to the graphics updates corresponding to that movement. So if there's a latency between those two, you feel like not very comfortable.
Yeah.
Typically, it has to be less than 50 milliseconds. Ideally, less than 20 milliseconds to make it comfortable. So traditional immersive telerobotics use a kind of fake way of immersive experience is by putting a gimbaled camera that's on the robot side, and then you have a that's mimicking the user's head movement.
Right.
So that's introduced a lot of latency because it's not only local computation, you're combining those latency on the video transmissions, moving the camera physically, all of those would introduce latency. So it's quite big. You can go up to 500 milliseconds if you're not careful on the implementations. But for us to render this, because we render 3D data already in the game, so we can completely decouple this transmission latency with those motion to photon latency. So whenever user moves their head, the game responds instantly, locally, does not need to receive data from remote.
So the camera doesn't move?
Yeah, the camera does not have to move.
Okay.
And it's all computed locally. So the response time is so low, it's quite aligned with the current VR gaming standard. For example, MetaQuest renders at 120 frames per second. That means about 8 millisecond latency. So you don't really feel, the user does not really feel any discomfort. So I remember seeing people on YouTube experimenting, wearing like Quest for a few days, living in the metaverse for a few days.
Wow.
It's a little extreme for that case, but but they didn't throw up, so that's a good sign.
That's good. Yeah.
Yeah. So that's that.
Okay.
And the third one, I would say, this control intuitiveness in the control in general, control schemes, to really allow anyone to operate the app straight away without training. So traditionally, users kind of stuck in the camera's perspective and has to train a lot to figure out how the control work with respect to the camera. So for those teleoperated robots, many cases you have multiple cameras. That means you have multiple screens, and you have to the operator has to switch perspective quickly. And all that adds up to quite substantial cognitive workload. So it's very hard to be a teleoperator, for example, for nuclear robots currently. So we kind of cleverly solved this problem with our VR application, where we create this interactive digital twin of the robots as a virtual simulation. Once user perform this kind of built-in automated hand-eye calibration, you can overlay those live 3D camera feed on top of the digital twin, and they overlay perfectly. When you interact with those digital twin, it gives you this feeling of you're really just next to the robots. And it's really natural. You know where you are relative to the robots. You kind of just use your gestures to operate them with everything around it. And you can use your hand tracking controllers, but also you can use your bare hand with available visual hand tracking features on the headset. We're kind of leveraging the latest development in those VR equipment as well. So all that adds up to a very, very intuitive scheme of interactions. So like 10-year-olds can easily use it. So my kid is like six years old. He played once or twice. He get the idea. Yeah. So yeah, it's super intuitive to do that.
Yeah, that's amazing. Obviously, the Jenga game was a nice kind of test case, a nice demonstration. But obviously, you're also applying this technology to some more serious real-world applications. And one that caught my eye was a collaboration that you'd done with researchers at the STAR Lab at the University of Surrey, who I've actually had on the podcast previously. And you were investigating the potential for human-assisted robot docking in space using this VR interface. And so for listeners who didn't know, I didn't know this before I started reading up about it. At the moment, this task is usually done on the ISS with robots acting autonomously. So can you explain, what are the benefits of bringing a human into the loop for this task?
Yeah, that's a great question. So really, as I mentioned, the reality is that robust automation in real world is extremely difficult.
Yeah.
Especially for those mission critical tasks like space operations. Having human in the loop, often a regulatory minimal requirement. So even majority of the time is automated. There's always has to be a human override option there. And from time to time, you have to use it. So the human in the loop is nothing new in these applications. Not to replace automation, but really as a assistance or fail-safe or ability to supervise the operations.
Yeah.
So docking maneuver for what we call serium adapter is kind of the standard adapter for docking in space. Is really common steps generally in the in-orbit servicing and manufacturing tasks. So it's not only for one specific. You can use it for servicing like refueling or docking two stations together or just assembly tasks in manufacturing in the space. There are many things that use this kind of adapters. There are many failure cases. For example, if you're using a visual servoing type of automation schemes for docking, so depending on the lighting conditions or visibility of the markers, sometimes it may fail. So in that particular test, we're showing the reliability and safety, and as well as flexibility to have this interface to allow people in the loop, and you can also switch between automations quickly with this remote operations. So additionally, with the 3D perception and interactive digital twin, it is also resilient to longer latencies in communication in the space, since the digital twin is almost acting as a simulation locally, just to bridge the delays, the gaps between the updates of the perception when people use. So the operator would already have an immediate almost feedback in simulation. So that helps on the space applications. So more recently, we have won a competition in European Space Agency and awarded a study contract with Airbus to develop the next generation interface for their robots in the space. We'll probably promote the news a bit later in the year.
Okay. Fantastic.
And also today we've just released a video on YouTube channel that showing our recent test in satellite applications catapult, their test bed, about replacing the satellite parts with robot arms and high precision 3D cameras. So yeah, we can check it out later.
Yeah, definitely. I'll go and have a watch of that. Cool. Yeah, that's awesome. And then before we finish, we had an audience question submitted on our website from Falk Zay, who says, your technology has the potential to revolutionize how we approach dangerous work. Could you describe potential applications in industries with inherently hazardous conditions, such as deep sea exploration, nuclear decommissioning, chemical handling, or disaster response?
Yeah, that's a great question about the market and commercial potentials. So the research and markets forecast really large global telerobotics market is 93 billion by 2028.
Wow.
Yeah, it's a big market.
Yeah.
So and our solution really enables general purpose remote working, extending beyond those traditional telerobotics applications. So on one side, we're still really valuable for those hazardous environments to liberate people from dangerous tasks such as nuclear decommissioning, utility inspection, maintenance, and even space applications. We believe we can also unlock a new, what we call the productivity value, that to facilitate this remote access to global labor and expertise, and accelerate adoption of robotics in high variability tasks in manufacturing, logistics, agriculture, and even general service. So really, we're tackling the entire labor market, really, everything that people do, and maybe even beyond what people currently can do, could be part of the scope. So we're really looking a big scope here.
Yeah.
And obviously, we're just getting started. So we're already in the market. So generated about $500,000 revenues through the sales of our product. We also started quite a few Innovate UK grant projects. Okay. So one example is a nuclear use case for remote handling of contaminated material in Alpha glove box. So we've been working with Atkin Realis for their robotized glove box projects to remove people from radioactive environments.
Yeah.
Second use case would be precision viticulture, actually, to many surprise. Okay. So we've led a consortium consists of Queen Mary University and Saffron Grange Vineyard, England, to collaboratively develop this robotic solution for grape harvesting and pruning solutions, really mainly to deal with labor shortage in agriculture and improve their product qualities in general. So this is a £1 million project that has been awarded by Innovate UK. And so we've started this project already. And by the way, the sparkling wine in Saffron Grange is pretty good. So,
that's just a perk of the job.
Yeah, heavily recommended.
Fantastic.
Yeah. And so also our system has been adopted by manufacturer customers to minimize their downtime with remote robot management, to easily monitor their production lines and allow them to rapidly intervene automated systems and even reprogram their operations on the go. So especially for manufacturers who typically have small patch of orders with high variabilities. So to our surprise, there's a huge amount of manual labor work, even in those heavily automated industries. So there's a potential that we can bridge the gap in there.
Fantastic. It's a really interesting and varied range of different things that you're applying this to. I think what you're doing is really cool. Excited to see what comes next for Extend Robotics and what projects you decide to work on in the future.
Yeah.
Chang, it's been great chatting to you today. I've been speaking to Chang Liu, CEO and Chief Designer of Extend Robotics. Thanks, Chang.
Thank you very much, Claire.
Thanks Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast and leave a review to let us know what you think. And make sure you check out our social media channels to see a photo of the Extend Robotics team performing a live teleoperation demo of pouring a pint of beer for BBC Dragon's Den. We're at Robot Talk Pod on all the socials. Next week, I'll be talking to Estelle Raffi from the University of Bristol, all about animal behaviour, intelligence, and lifelike artificial systems. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.